Now we are going to study the impedance matching in transmission line. Why impedance matching is required? So for the purpose of maximum power transfer and to avoid the reflection, impedance matching of transmission line in a load is required. Main techniques are the LC using the passive component, L or C component, lambda by 4 or the quarter wave line, which is also referred to as the quarter wave transformer. Then single stub matching, where the stub or can be connected in the series or in the shunt, and a double stub matching. Basically, the stub is a piece of transmission line which is the length and the place from the load at which it is connected. These two parameters are necessary to provide the impedance matching. So here we discuss the single stub matching. Here the reed line which is connected as a stub, it is connected in a shunt with the main line. So here is a main line which is terminated in the load impedance ZR. Z0 is the characteristic impedance of the line. Naturally, Z0 is not equal to ZR, so there will be reflections. So from the load side, the stub is connected at such a place, that is D stub. So that this is one parameter, and second parameter, the length of the stub is adjusted in such a way so that from this point onwards there won't be any reflection in the line. So these two parameters are important, that is the length of the stub and D stub. This line, the piece of the line which is used to make the stub has characteristic impedance ZOS. For practical purpose, the same line is used as the main transmission line, but it is not mandatory. Any piece of line having some different impedance can also be act as a stub, but normally, practically, the ZOS is equal to ZO. The same piece of line is used to make the stub. If the same stub is connected in series of the line, it is called the series stub matching. And in place of single stub, if one more stub is used, then it is referred to as the double stub matching. So here, as the line is connected in the shunt, we consider the admittance. So we convert all the impedances into the admittance. And from this point onwards, we find a point where the resistive part of the load is 1. That is, resistive part of the impedance matches with the resistive part of the transmission line. Okay, so it is the place where the stub is connected, and now at that point there will be some reactive part. So we adjust the length of the line in such a way so this line will provide the opposite admittance at the same place. So both the admittances will cancel each other, and we get the perfect matching of the line with the help of the stub. So these two parameters, the D stub and the length of the transmission line, these two parameters are adjusted.